all the resistances RA, RBC are known. I think the value of RA, RBC are given, and their values are indicated in the diagram. All the voltmeters A, B, C are identical. If the readings of the voltmeters A and B are 7.5, find the reading of voltmeter C. No, it didn't say all the voltmeters A, B, and C are identical. I'll just underline this. Reading of voltmeter C. No, it's not ammeter. Voltmeter. So next, one more thing. One very big thing, like, are they ideal? If they're ideal, then what conditions will arise? So what I should do with, I think straight away you should have asked this particular question. Like, so let's assume that if they are ideal. If they're ideal, this will happen, no? Can we do anything here? That's what, if voltmeters were ideal. If voltmeters were ideal, that's what happens here. So we can't do anything here, no? No current will flow this branch. No current will flow this branch. So definitely what happened, the voltmeters are not ideal, that one. They are practical. If they were ideal, this would have been the situation. And if you write loop equation as no current flows, then VAB equal to VB equal to VC. If they were ideal, all would have read same. I'm supporting all would have been same if they were ideal. Because what do you mean by ideal voltmeter? In place of ideal voltmeter, what you should replace? Open circuit. In place of ideal ammeter, short circuit. Are you getting now? Errors in a circuit. If you see voltmeter, if the ideal, replace with open circuit. If the ammeter, short circuit. Then is it possible VA, the drop across these 2 points, equal to these 2 points? Because no current will flow in this branch. No current will flow. If you write KVL, then this drop must be equal to this drop. I'm indicating this one. See, it's like a no, you have to really take help of the basic things. Now you can ask one more question. Sir, you only said to measure voltage, the voltmeter should be connected across some element. There is no element. Then why you are connecting? Is to trouble you with some question. It's not that the voltmeter must be connected. I don't want to measure any voltage. Just I'm bringing voltmeter here. The purpose of these voltmeters are not to measure any voltage across element. They just I introduced like some resistor it is. Because what is it basically an voltmeter? It's a resistor. That's all over. So I have this idea. It is just like one resistor where it will also read what is the drop across it. If it were ideal, this would have been that one. If voltmeters were ideal. So since the VA is not equal to VB, so therefore they are not ideal. Now come to the real problem. Sorry, they didn't mention. Yes, definitely looking at the VA, VB, what pen you're supposed to make a guess. This will be, so it will have some resistance. So I'll write RA, not ammeter resistance. It is RA, already symbol is there. No, I'll write RVA. RVB. So this is RVC. We have the information of this 9 ohm, 14 ohm, and this is 24 ohm. What is this drop? We have information of this drop, the potential drop. How much it is? 7.5 volt. We have information of this. It is equal to how much? 5 volt. Is asking us to calculate this drop. So let's assume that let there be some current flowing through this. IA, IB, IC. So these are the polarities. The same current will pass through this one. No? So what is 7.5? So let me go with the mathematics. 7.5. The Ohm's law across the voltmeter A. 7.5 should be equal to IA into RA. Next, one more thing. You look at this one. I indicated all the voltmeters are identical. So what is the advantage now for me? Identical means all will have same internal resistance. I just took help of the condition given. Then similarly, the 5 volt across should be equal to IB into RV. Divide these two. So IA by IB should be equal to 7 point or 3 by 2. This is equation 1 you keep in mind. Let's write loop equation. 9 RA. RA value we know it. IA into, oh sorry, this is IA into 9 minus of, and I'm going to for the loop here, minus IA into 9 minus 7.5 plus 5 plus IB into 14 equal to 0. I'm applying KVL minus IA into RA. RA is how much? 9 ohm, no? Okay, from solving this, we'll get relation between IA and IB. Here, what we have one equation, so this will be minus IA. RA is minus 9. IA 7.5 plus 5, so this will be minus 2.5. RB value is 14, so 14 IB equals 0. So I know the equation 2. Solving this, I'll get IA and IB. Once if I know IA and IB, once I know IA and IB, then similarly I'll calculate IC. And once if I know I and IB, I'll calculate RV. I'll substitute here. After knowing RV, then I'll apply KVL, I'll get IC. Then what happens? I know RV value, then I'll get the VC. I'll proceed further. So this should be equal to one more loop equation minus IB into RB minus 5 plus VC plus IC into RC equal to 0. We know value of IB. Then VC is equal to VC and we know VC, we don't know VC and sorry, this is the RV, no? RV value I'll calculate it from here. Solving 1 and 2, I'll get IRB, then I'll get the value of RV, I'll keep it here. So VC and IC, two unknowns are there. So one more thing, what we can write it as like VC is equal to IC into RV. What you get RV value, substitute here.
RV is 1, sir.
RV 1, sir. IB 5 amperes, IA 15/2 amperes.
IB how much?
5
IA?
ampere.
5 amperes.
IB?
Sir, IB is 5 amperes, sir.
12, huh?
No,
No,
sir.
sir.
IA is 7.5.
IA is 7.5.
IB is 5.
IC 3.
IC will be 3. Yeah. So we'll get VC. Anybody value VC?
3.
3 volt, huh?
Sir.
Yes, sir.
Maximum numericals, it should be something related to KCL, KVL, or V-Stone network, or something different. So nothing to do with any very big idea of the voltmeter ammeter.